I would consider it more of, I would consider it a different class of tunnel interface.
All right. Well, because it's not GRE,
Correct.
but isn't transport more efficient than tunnel? And
It,
VTIs are, like, by definition, more efficient.
it is, but it's not using GRE. It is because it's not using GRE.
All right. But I
And
thought VTIs,
it's working in a similar way to transport mode.
yeah. This is a little bit confusing.
All right, and then you are aware of the configuration for the VTI tunnel interface, right?
It's very similar, and I know there are configuration guides in the docs for that. I mean, I know for a fact there are.
Yeah, but
It's
you
very similar to what I'm used to.
okay? Um, so one thing I should probably mention is that um, you might have to configure a VTI tunnel interface with different VRFs.
I've never done that. I've never done MPLS encryption. I've done DMVPN encryption.
Okay.
And normal, I've done VTIs and I've done GRE over IPsec, but I have not done MPLS.
Well, this isn't MPLS encryption. This is just so you might have a router. Okay, this is our router, and then we're going to have two VRFs, and then on one VRF we're going to have, this is going to be our inside trusted network, and then on our outside we're going to have the outside untrusted. And so when you're using VTI interfaces, one sort of benefit that you can have is, so that's our trusted zone, and that's going to be inside. That's going to be outside. So one nice thing that you can do is you can have your IPsec terminated or live, your IPsec tunnel is going to live on the outside VRF, but your GRE tunnel or your internal IP tunnel is going to live on the inside. And these are both going to be located on the same router. And the benefit about this is that in the situation that, so in terms of the old IPsec tunnel that we used to have, if that IPsec tunnel ever went down, that link that we have the tunnel on, that's still on the public internet, right? And we could inadvertently try to forward traffic out of that interface if we don't have an ACL that's properly configured and the routing lets us to do so. Right? Because otherwise, if something is not going to be encrypted, if something doesn't get encrypted out over the tunnel interface but is still going to be routed over that interface, it's just going to hit the public internet, and then whatever corporate traffic that you wanted to be encrypted is going to be out on the web, readable by anyone who happens to be in the middle. Okay, so this top sort of scenario will actually let you. This top sort of scenario will let you have a private VRF or an inside VRF and separate out that from the VRF that you're using to communicate with the public internet. And in the case where your tunnel interface goes down, your traffic that happens to be on the inside is going to have no way of getting out to the untrusted side, because that IPsec tunnel was the only thing kind of bridging the two things. Okay, so does this scenario make sense?
Yeah.
Can you please go over through it again?
Okay, so what we have over here is we basically have two
The mic?
sites. Yeah, we have two sites that we're going to want to configure with a VPN between them. And when you're normally configuring a VPN, or when you're configuring two sites connected with a VPN, you're going to have a router. But that router, those two routers that are going to be connected with each other, they might happen to straddle multiple security domains, right? You're going to have one interface that's going to be connected to your private LAN, and then you're going to have one interface that's connected out to the internet. And so if you don't properly secure this internet connection, you might happen to forward out traffic over that internet connection that you wouldn't necessarily want to. Okay, because this router is going to have a default route that points out towards the internet. And normally you would have had a tunnel that would have given you more specific routes to go over the tunnel to reach a remote network on the other side. Okay, but if that tunnel were to go down, your router would still forward traffic via the default route. So what you want to do is, normally when you have when you have this sort of setup, and kind of think the original model, you would lock down that kind of traffic with an access list, right? You would say none of my private IP addresses can communicate directly with the outside world unless they're NATed or something like that. Or none of my private IP addresses can communicate with other private IP addresses coming out over this public network or over this interface. Now, if you're using the VTI interface, or not, yes, okay. So if you're using a VTI interface, what that allows us to do is, one, it allows us to have a tunnel, establish an IPsec tunnel on one VRF, and it lets us re-terminate that tunnel, or the interesting traffic that's going to be encrypted over that tunnel, in a different VRF. Okay? And the benefit about this is that there's no bleeding of traffic from one VRF to the other VRF. The traffic that belongs to that traffic that was meant to go to one VRF sticks in that VRF. And so if we wanted to make sure that our inside traffic stays inside and is not going to inadvertently get routed to out a default route or out a default path that it shouldn't normally get routed out of, then this would be the way to do it. And then another benefit of this as well is, if you're using VRF Lite, and let's say we had a third security zone on this router, we're just going to make this down over here our DMZ. So if we had a third security zone as well, we could use that same IPsec tunnel that we were using before. And we could use that same tunnel that we were using before. And then make sure that our DMZ traffic between these 2 points is only going to be allowed between these 2 VRFs. So if we wanted to have traffic, if we wanted to have tunnels that were pinned to specific, if we wanted to have VPN tunnels that were pinned to specific VRFs, we'd be able to do that fairly easily if we were to use VTI tunnels. And the benefit about this is that the traffic that wants to be or that needs to stay in one security zone is allowed to stay in that same security zone. Okay, and so this could also be, rather than that being like an inside VRF and a DMZ VRF, that could be, maybe you're an ISP and you have customer A, customer B, customer C, customer D, but they all want VPNs to each other. And then how would you isolate that traffic? And then how would you make sure that that traffic stays in that VRF? Well, you would be using this in order to do that.
What topic would that be under if I wanted to read more about it?
This would be under, I would say VRF aware, VTI tunnels.
Alright. I wonder if that is in the docs. Might not be. I don't think VRF Lite is on the exam, though.
Really?
I didn't see it.
But they have MPLS still.
They do.
Yeah. VRF Lite is just like VRFs with static routes, right?
VRF Lite is, did you say it was just a bunch of static routes?
No, I said VRF with static routes.
It's, well, not necessarily. I mean, it's just, you're using VRFs to segment to partition the network, but you're not using MPLS.
Okay.
Okay, so when you're using MPLS, you basically have a backbone that's going to be distributing information among all of the different VRFs. But if you're using VRF Lite, you are segmenting the router into multiple VRFs, and then you can run parallel routing protocols or parallel networks on top of the same routers.
So, Kit, now, to what you just said, now when you create your VRF, let's say we created a VRF for the internet traffic normally, right? For the green line?
Yeah.
Yep. And then you create your traffic for the inside. You create another VRF for the inside trusted zone, right?
Yes.
Now, I'm kind of like a little bit confused on that part. Is which one do you secure? You definitely need to secure the outside on trusted zone, right?
Yes.
Now, now the inside, your inside traffic when it's going through that VRF, is it being secured too, or not?
So your inside traffic, when it's over before it hits the router,
Yes.
your inside traffic is going to be unencrypted. So at this point, it's unencrypted, it's unsecure. We're treating it as trusted, right? But in order for it to come out towards the over the tunnel, it has to be encrypted. Otherwise, it would have no reachability over the green path. It actually doesn't know that the green path exists or that this outside VRF exists.
Okay.
Okay? What's going to happen is that we're going to create a tunnel. That tunnel is going to be on the inside, but we're just going to tell the tunnel that it should establish its tunnel endpoints on the outside.
Okay.
Okay, so the tunnel stays the tunnel itself stays in the right zone, but the where the tunnel gets terminated is going to be in a different zone.
Like the source and the destination.
Yes.
Okay. Thank you.